Welcome to Mr. Craig's first attempt at trying to teach one of these lessons with the tablet and the flipped classroom. Alright, so here we go. The first one we're going to try here is about section 5-3 and 5-4 in your book. 5-3 is about the inverse cosine function. Now, we've been using the inverse cosine function already because we were doing law of cosines, and a lot of those problems ended with trying to find the cosine of an angle. Sorry, you had the cosine of the angle, you're trying to find the angle itself. And for that, you just put in inverse cosine in your calculator and inverse cosine of the cosine you know, and it gives you the angle at hand. The thing with that, though, is that's always going to give you an angle between 0 and 180 here for this one. This one we did here where we knew the angle was 5/8. Sorry, we knew the cosine was 5/8. We found inverse cosine of 5/8, and it gave us an angle of 51.3 degrees. And from what you know of trigonometry, you would realize that there are lots of angles that have a cosine of 51.3 degrees. It gave us 51.3 because that's the one it figures we probably want. We probably don't want angles like these because those are kind of strange. Sometimes you do want angles like those, but you have to take this angle of 51.3 and convert it into the correct quadrant. Okay, again, that's just review because we did a lot of that in 5-2. Okay, the cosine inverse is always going to give us a value between 0 and 180. And of course, because cosine, normally cosine only has a range of -1 to +1, the domain of the inverse cosine is going to be also that, -1 to +1. You can only put a number in for inverse cosine if it's between -1 and +1. If you ask your calculator to find the inverse cosine of 5, it's going to give you an error because there is no angle that has a cosine of 5. All those coordinates on the unit circle have a cosine value that's between -1 and +1, so the input on inverse cosine has to be in that zone also, -1 to +1. And when you do that, of course, it's going to give you something in the first two quadrants because that's sort of the normal region you would want it in, even though there are other angles in quadrants 3 and 4 that have that. So in degrees, that's 0 to 180, and in radians, that's 0 to pi. Okay, so let's do one of those problems from scratch. So you're not just looking at me doing it, already done like in your notes. So let's say you're doing some law of cosine problem where you had, your a squared plus b squared minus 2ab cosine c equals c squared, and you had some triangle, and you knew some of these values, like we knew all three sides of the triangle. Say, oh, that looks like a right triangle. Let's pretend it's not a right triangle. Let's say it's, oh, this will make it not be a right triangle. If I go 3, 4, 6, I happen to know that's not a right triangle. Okay, and let's say we're looking for, oh, I don't know, this angle here. So we're going to call this one C. In this problem, I'd have something like the included sides would be A and B here, the sides that are on that angle. 4 squared plus 6 squared minus 2 times those sides. And 3 gets to be the one by itself because that's the one that's opposite the angle in question over here. And then I need my calculator to do all this stuff. Be right back. Okay, 4 squared is 16. 6 squared is 36. 2 times 4 times 6, that's blackout here, 48 times some unknown cosine equals 9. Don't forget to bring down this negative. People forget that all the time. I'm going to take that 9, I'm going to subtract the 16 and the 36 from it. We get -43. Don't let all these negatives scare you. In fact, these negatives are your friends. If you don't keep these in here, you're going to get the wrong quadrant or something. And this is negative 43. Negatives don't want to show up. Minus over negative 48. Dividing both sides by negative 48. That gives me some wacky decimal like 0.895. You don't need to find this one. I'm just doing this here for reference so you know what this looks like, kind of to estimate this. So we have an angle whose cosine we know. The angle has a cosine of 0.895. I go to my calculator at this point and I go, okay, tell me the inverse cosine. Tell me the angle whose cosine is 0.89 blah blah blah. And that will give me an angle. If my calculator is in degrees, which it is, I get 26.38 approximately degrees. And that's the measure of angle C up here. Okay, so there's one of the most common ways we're going to need to use that inverse cosine. Let's talk a little more about the function of the inverse cosine here. This black picture here, this is our old friend, just the cosine of x. And it's in radians. So here it starts at a value of 1. The cosine is 1 when the angle is 0, and then it goes through its little cycle here, as you remember, and it completes that cycle by 2 pi. And so, you know, the cosine of 0 radians is 1, the cosine of pi over 2 is 0, and as we keep going over here to pi, the cosine gets to its minimum at negative 1, and that's what you're used to seeing for cosine. This one's cosine. The inverse cosine, you remember, was like taking that graph, if you wanted to see what the graph looked like, and reflecting that graph along this line, which would be the line y equals x, that kind of thing. That would be the reflection line for how to figure out where the inverse is. And then if you do that, you notice you'd kind of get this thing be over here, and it would reflect, and that'd be part of it, but it would actually have all this other stuff too. Like it would look like that down there. It would kind of keep going down here. It would do this crazy sideways sine wave thing. Well, we don't want that, because now if you look at that, that's not going to be a function. That would definitely fail the vertical line test. We'd have all kinds of problems with that. So they restrict the domain and range of inverse cosine so that it is a function. And really, we don't want, as I said before, we don't want inverse cosine to give us all these different angles and have this ambiguous answer for you know, what the angle could be if you just know the cosine. So they just have it talk about these angles here in the first two quadrants. So inverse cosine, the first value you could put in there, the lowest value you could put in as an x, you know, if you're trying to find the inverse cosine of something, the lowest cosine there is negative 1. So that's why this starts here, this first point here. Oh, you know what? I could put a point on here, and we could talk about the coordinates. Oh, I missed. See? Drop that point right on there, and then I can measure its coordinates, and we can talk about how it's changing. What is going on? Okay, so here's the coordinates of that point I just put on there, and I can move it around, and you can see how the coordinates change. So here, if I drag it all the way over there, the first value of, you know, the sort of minimum x value that could have, that could put in for inverse cosine is negative 1. You can put in values from negative 1. I'm watching the x value here, from negative 1 all the way up to positive 1, and that's all that can go in for for inverse cosine. Then at here, basically, I'm asking, okay, what is the angle? This is in radians now. What is the angle in radian measure of the angle whose cosine is negative 1? I know the cosine first, and I'm trying to find the angle. If the cosine is negative 1, then the angle is pi. And as I move up the function here, I can ask any of these numbers between negative 1 and positive 1. And as the value of x, basically down here, starts to go up, then the value of that cosine starts to come down. Because if you think about the unit circle, we're coming from a cosine value of negative 1 is pointing completely left. And as we come up and the cosine increases, we're talking about values of cosine that will be closer to, well, this would be 90 degrees, right? This would be like half pi over 2, which is 1.57 or so. And then eventually we'd come all the way around the circle and get over to pointing completely straight over to the right, which would be at 0 degrees, which is the answer here, when the cosine is 1. And these are exactly the same values, but just x and y is switched, like all inverses do, of this branch right here of the cosine value. So if we look back at your notes, you could take that old picture you had, that old table you had for the values of cosine, and just make a table like this that has the reversed values in the inverse. If you wanted to find the inverse cosine of -1, well, that's 180 degrees. And the inverse value of the inverse cosine of 1 is at 0 degrees. And everything in between operates as such. Now, the ones I happen to put in this chart, these are the ones with the exact values from that last unit we did. So this has all the exact values of cosine that we studied from -1. I put them in increasing order from -1 all the way up to 1. And in that order that we'll be talking about cosine of when the cosine is -1, the angle will be 180, then all the way around the top half of the circle till we get back to 0. If the angle is 0, the cosine is 1. So the types of problems you're going to get, other than maybe law of cosines, where you have to apply this, use the inverse cosine function. You might get a regular old right triangle, and you don't know this angle, but you know some of the sides. Say we know that's a right triangle. The cosine would be the one that would be adjacent over hypotenuse. So inverse cosine would be helpful in a situation where maybe you knew this side, and you knew this side, and you were trying to figure out what that was. Because as you know, the definition of cosine is from SOHCAHTOA. It's adjacent over hypotenuse, which here is exactly the ones we're talking about. So in its sort of, I don't know, first basic use you'd ever need inverse cosine for would be something like this. So let's not forget about that. Inverse cosine of 5/7. Well, that's pretty simple. Put that in your calculator. 5/7, and it says it's approximately 44.4 degrees. That's not a half bad picture, but this isn't perfect, so let's say it's approximately. Well, thank you for watching my first video on the flipped classroom, and this would be section 5.3.